Okay, problem 8.2.7a. So the question is to use the Gram-Schmidt procedure to find these first four polynomials over the interval 0, 1, where the weight is just, I think the weight is just default by 1. So in this case, this is just the Legendre polynomials. And here we're going to just use the recursive formula, which is which is equivalent to the Gram-Schmidt, but it's simpler to use. So for recursive formula, we just need to first compute the first two polynomials, which the first one is phi 0, which is always set to 1. The second one is phi 1. So here I think I should divide it by the phi 0 w. So in this case, x is the second like the fundamental basis, right, of degree 1, and then multiply this to the phi 0 with the weight equals to 1. So now here the x times the phi 0, weight is 1, so we just need to take integral of this. So this part corresponds to this part, this integral, or this inner product. The phi 0 itself is just 1 here. The denominator omitted because you can easily see that the denominator is nothing but the 0 to 1, the 1 times 1 dx, which is just equal to 1. So that's why the denominator is just equal to 1. So we can ignore it. So here we will get the phi 1. So once we have the phi 0 and phi 1, we can use the recursive formula for the next one, phi 2, we just need to calculate the b2 and c2, where b2 is given by this formula, which is x phi 1, and the phi 1, phi 1. So the only difference is here, there's extra x here. So we just need to plug in the phi 1, which is this. So now for the numerator, that becomes x times the phi 1 times phi 1, which is just the x minus half squared. That's the numerator, and denominator is just the phi 1 times phi 1, which is this one squared, and take the integral. So that's what we get. Now for the numerator, it's actually, we just need to expand this, and we'll get that, and then take an integral of this. So that's very straightforward, because it's just a polynomial. Taking integral of that, we'll get the 1/2. That's the value of b2, and for the value of c2, that's just a formula like this. Okay, so you can see that's 2 here. Then this has to be reduced by 1. This has to be reduced by 2. So that's x phi 1, phi 0, and then phi 0, phi 0. So x phi 1, this is x, this is the phi 1, and the phi 0 is just 1. That's why we have this. For the numerator, denominator is still just this. And then we take the integral, that becomes the 1 over 12. So now, using the recursive formula, which is this, so phi 2 should be equal to this. And now we just need to plug in the b2 is here. Phi 1 is what we already got in right here. And then c2 is right here, and phi 0 is just 1. So that's why when we plug in things, we'll get this. Okay, you can do this for the next one. A little bit more computational expensive, but the procedure is exactly the same. You're going to use this recursive formula, and eventually you will get to this one. So that is phi 3.